Okay, starting lesson 1.6. Example 1, write the linear function f such that it has the indicated function values. Okay, this problem is not very much different from problems you've been doing all throughout algebra. Remember this problem where they would ask you to write an equation based on those points? Well, what we have here is the same thing. This is like your x1, that's your y1, that's your x2, that's your y2. Same thing, just different format. All right, so we first have to find the slope. So I have -8 for my x1 minus 2 for my x2, and then x1, which is -3 minus 1. So slope formula is y1 minus y2 over x1 minus x2. All right, so I have -10 over -4, and I get 5/2. All right, so now I have my equation, y equals mx plus b, y equals 5/2 x plus b. Now choose either set of points to figure out what b is. I'll plug in the second values. All right, so I have 2 equals 5/2 plus b, subtract 5/2. So I have 2 minus 5/2 equals b. Put this over 1, multiply top and bottom by 2. So b is equal to -1/2. All right, so completing my equation, I have y equals 5/2 x minus 1/2. All right, and using function notation, I can replace y with f of x. They are the same thing. All right, what's the difference between the two? By stating this, you're saying that this passes the vertical line test. So if something passes the vertical line test, it is a function. So that's why I'm replacing y with f of x, showing that the equation is a function. All right, so this is your answer here in the green box. All right, going on example 2. All right, use a graphing utility to graph the function. Be sure to choose an appropriate viewing window. All right, this is a great opportunity to learn how to use your calculator. All right, so if you need help with that, just let me know. But using the trace function or the table, we'll figure out what these points are and graph the function on the grid that you're given. All right, same thing for the next one. And eventually, you won't need a calculator, because if you look at your yellow sheet, all right, there's a list of function transformations. And if you notice the relationship between the structure of all the functions, you'll be able to graph any function super easy. All right, if you need any help with that, let me know, but we're going to get to that in a future lesson. All right, going on to example 3. All right, the greatest integer function. All right, if you have these like double brackets around a value, that means you're applying the greatest integer function to it. And what this does, very simply put, is it takes the number and it shifts it back or to the left along the number line to the closest integer. All right, so for example, 2.5, if you move to the left, what's the first integer that you'll hit? 2. For 1.2, if you're on the number line and you move to the left, what's the first integer that you'll hit? 1. How about 0.4? Remember, you're moving to the left. 0. 3, if you're already at an integer, you don't need to move at all. It's just the integer itself. All right, same thing with 5. All right, -1.2. Be careful here. Remember, we're moving to the left on the number line. So what's the first number that's an integer to the left of -1.2? That'd be -2. -2.7. Moving to the left, we get to negative 3, negative 0.6, negative 1, negative 0.1, negative 1, and 7.9. All right, remember, we're moving to the left, 7. Okay, so here in example 3, evaluate the function for the indicated values. So I'm going to take 2 and then multiply it by the greatest integer function of negative 3. Well, what's the greatest integer of negative 3? It's just negative 3. All right, done with that. All right, then we have 0.25. All right, well, what's the first number to the left of 0.25? That's an integer. That would be 0. Answer 0. All right, what is the first integer to the left of 9.5? It's going to be 9. And what is the first integer to the left of 11/3? Now, it may help to first convert this to a mixed fraction. All right, well, it's going to be 3. So answer 6, all right? So once you get familiar with this function, it looks a little crazy, all right, but it's actually really simple to work with once you understand it. All right, moving on to the next example. Okay, here we're going to sketch the graph by choosing a bunch of x values. Now, it's your choice which x values you want to choose. All right, here are the ones I'm going to choose. 0, 0.5, 0.9, 1, 1.7, 2, negative 0.1, negative 1, and negative 1.8. All right, plug all these values into my greatest integer function. What do I get in return? 0, 0, 0, 1, 1, 2, negative 1, negative 1, and negative 2. All right, so at 0, I'm at 0. At 0.5, I'm at 0. And at 0.9, I'm at 0. But at 1, what happens? It jumps up. Okay, so I'm including this value, and I go to the right here. And then at 1, it jumps up, so I don't include this value here for y. So that's why I put an open circle. And then so I'm jumping up, and it includes that value here for y. And then I have 1.7, I'm at 1. And then once I hit 2, I jump up to 2. Okay, so when I'm at 2, though, I don't include 1. Because that's where it jumps. That's an open circle. All right, and we can move to the right as well. You'll notice the pattern repeats, and it's going to go backwards as well. All right, once you understand the pattern, simple stuff to do. All right, going on to part B. The values I'm going to choose are 0, 0.5, 0.9, 1, 1.7, 2, negative 0.1, negative 1, and negative 1.8. Okay, plugging these values into my function, what do I get? I'll get 0, 0, 0, 4, 4, 8, negative 4, negative 4, and negative 8. Okay, so at 0, I'm at 0. At 0.5, I'm at 0. At 0.9, I'm at 0. And then at 1, I jump up to 4. All right, so right here it's a solid dot. And then I'm going to the right. And then it's going to be open because it doesn't include that y value. But it does up here. All right, then at 1.7. Then at 2, I jump up to 8. All right, that's going to be an open dot there. All right, then we'll go backwards as well. All right, that's all there is to it. Moving on to the next example. All right, piecewise function. Okay, just imagine this wasn't here, and you were graphing this equation, this line, and this line. Except something's happening here. I don't want the whole line. I only want this portion of the line where the x values are less than or equal to -4. And I only want this portion of the line where the x values are greater than or equal to -4. Alrighty? So let's see what's happening here. Alright, I have a slope of 1/1, and I'm starting off at 6. Okay, and I go up 1 to the right 1, up 1 to the right 1. Okay, I'm going to do this in red. So now I'm starting at -4, and it's less than -4 for the x values. So here I am at -4 for the x values. I'm going to include that value, so I'm going to put a solid dot there, and I'm going to the left, because I want all values, all x values for my line to be less than or equal to -4. Alright, there's that. Alright, then for the next one, let's do this in green. Alright, so I'm starting at -4, and then my slope is up 1/2, down 1, back 2. Okay, I'm going to do this one in red as well. Alright, so I want all my x values for my line to be greater than -4. Alright, greater than, not equal to, just greater than. So it doesn't include this value, but it includes all x values to the right of that for the line. So then I go this way. Alright, and that's why it's called a piecewise function, because you're just taking pieces to the graphs based on the restrictions given. Alright, going on to the next example. Alright, write the equation for the function shown on the graph. Alright, whenever you're looking at a wave-like graph, that's going to be a radical, or in this case a square root. So this is simply f of x is equal to the square root of x. Alright, now look at what happens here. This is my starting point, 0, 0, but what happened? It shifted back 3 units and went down 1. Alright, so when you're shifting back, that means something is happening on the inside of the square root. Alright, so if you shifted back, you're going to the left. Often students think that means you're subtracting, but when working with the function and constructing it, you actually put the opposite value there. So if I'm going back 3, minus 3, I'm actually going to put plus 3 inside the function. And then whatever happens with regards to moving up and down, you put that number on the outside, but you stick with the sign. So if I went down 1, that's minus 1. So I just put minus 1 on the outside. So whatever sign you have inside here, you're doing the opposite of that. But whatever sign you have on the outside here, that's what you actually did. Alright, so there's my function there. And then what happened to the graph now? It has the same starting point, but it flipped. Alright, and when that happens, and it flips over the line that passes through the starting point here, it essentially reflected over that line, right? Alright, when that happens, you throw a negative in front of the function. So it's going to be x plus 3 inside and minus 1 on the outside. Alright, to get a better idea of how this all works, to grasp this idea and understand the underlying relationship between all functions, just look at the graphs of transformations that are shown on your yellow sheet. And then once you grasp that, you could graph any function super easy once you understand that relationship. Alright, so if you have any questions, let me know. Begin the assignment at the bottom of the webpage.